Did this begin? Yeah. So this is live. I'm going to be going through the book Build Your Own Lisp. Now, why it does seem like I jump back and forth between things, but again, as a lot of the stuff for writing an OS is basically written in C, not so much in Rust. And also, I kind of the way I learn things, it's by a lot of it's by comparing this and that. So I also think that through learning a bit of C, and this book isn't too long. This book isn't too long, and the thing I like is because it has a one very big project. So to write a Lisp interpreter in C. And so it's not just like chapter per chapter, little small programs. The other thing is that I'd like to build maybe more appreciation for Rust by doing a bit of C. And that way, when I do Rust, maybe it will be, yes, as I said, to build more appreciation for Rust. And the second thing is I want to do this course about MIT operating system engineering, which kind of works on XV6 and tries to extend it with the C language. So this is kind of a teaching OS that I read. Kind of, you really have to go through this. You really have to. It's good to go through this to understand how an OS works. So I'm going to start with Build Your Own Lisp, and then if this doesn't work, I'll just go back to Rustlings. At the same time, I will try doing the Rustlings along with this, and I'll just see how it goes. I was kind of not sure if I want to really start now this, but I don't want to leave out the Rustlings. So it's kind of yeah, I'm still switching back and forth from this or that tutorial, but I hopefully I'm going to, what's the term, hopefully these kinds of, couple of roads that I've taken will somehow come together. Also, a shout out to Alka Crab Game. How is my encoding overloaded? Maybe it's just too much, or I'll stream this. Actually, I'll do this on my phone. I'll do this on my phone because it's just easier. So, and C seems to be very, simple. Build Your Own Lisp. I like that the book does not start here. So this is already like chapter 3. And I've skipped like basically 2 chapters where he writes about it and how it's going to be and such. But I'll just gonna start here. So a program in C consists of only function definitions and structure definitions. It's kind of nice that he doesn't start by saying that's just how I see it. It doesn't start by saying that. It starts with statements, this and that, and this and starts this and starts that. So a program in C consists of only function definitions and structure definitions. So it's almost like I'm reading a book about functional programming. So therefore, a source file is simply a list. It's interesting that he says a list of functions and types. Maybe because this is kind of constructing or building a Lisp. And so he's kind of using these terms maybe as a Lisp programmer. So therefore, a source file is simply a list of functions and types. What's also interesting that Tsoding, the streamer Tsoding, has a really long stream of building a VM in C for his Lisp interpreter. So if I build this in C and I build Lisp, then I could basically go along building the VM in C for this Lisp, and hopefully I'll have more depth to it when I follow Tsoding, because it's not just about the language. I've been stuck kind of always learning about languages, and that was very interesting. But if you never build a thing, it's really hard to kind of to kind of have sense of all what's going on. I've been studying for so many years and reading about languages and such, but when you never build a thing, you end up just kind of being in this realm of enjoying reading about languages and functions and types. But when you actually try to build something, you just don't have the meat to it. You've never built something, so it's like you read about a language, but you never describe a thing using that language. And kind of programming, and that's my idea now. So Build Your Own Lisp has has a big project from beginning to an end, where basically by learning C, you learn how to describe and interpreter in C, like you will build it. So hopefully I'll get more meat to it, and then I will have somehow more depth, to when I, for example, learn Rust or something. Anyway, I'll just start. So therefore and I'll see how this goes. If this does not go too well, I'll just return and do Rust until the end, and anyway, we'll see. Therefore, a source file is simply a list of functions and types. These functions can call each other or themselves, and can use any data types that have been declared or are built into the language. I kind of want to change this. Maybe I don't want now, music. It's possible to call functions in other libraries or to use their data types. This is how layers of complexity are accumulated in C programming. So a source file is simply a list of functions and types. These functions can call each other or themselves and can use any data types that have been declared or are built into the language. Right, it's possible to call functions in other libraries or to use their data types, right? So this is how layers of complexity are accumulated in C programming. As we saw in the previous chapter, the execution of a C program always starts in the function called main. From here, it calls more and more functions to perform all the actions it requires. Variables. I think there was a hello C, hello world in C. I guess we skipped that. We skipped that, right? Wait a second. Chapter 2, installation. We did install GCC. CC. I see this. Create a directory. We're going to put your work for this book. All right. Someone says I said a lot of the times, all right. Okay, wait. Build Your Own Lisp. I'm here. And let's do hello world. So is this like snake case? It's still, it's snake case. Hello world. And include studio H. So that was like in Rust. Include, it was just written a bit, different, but still is the same idea. Include standard input output H. there's a space after include. And then we're going to do int main and int argc char star star argv. And now we have puts. It's not printf, I guess. Hello world. And also semicolon and return semicolon. No, return 0. So we are actually returning here. Int main argc char v puts hello world return 0. All right. Now this, so let's save this. This make, in the first line, we include what is called a header. So this statement allows us to use functions from standard input output H, the standard input and output library, which comes included with C. One of the functions from this library is the puts function you see later on in the program. Next, we declare a function called main. The main. So we have a main, we have a main. That was like in Rust, yeah. So this function is declared to an input in int and take as input an int called argc and char star star called argv. All C programs must contain this function. All programs start running from this function. Inside main, the puts function is called with the argument hello world. This outputs the message hello world to the command line. The function puts is short for put string. The second statement inside the function is return 0. This tells the main function to finish and return 0. When a C program returns 0, this indicates there have been no errors running the program. Now, this kind of sentence is maybe confusing. To me, like, why do you have to put here return 0? Maybe maybe ChatGPT will know. So this sentence is kind of confusing. Why one must write, and now I'm going to copy paste, because it looks like I am indicating in the source code that there have been no errors. Why would I declare that right in the source code? I'm not sure how to explain, but it's like I'm doing something, and at the same time I have to say there will be no mistakes. But then, do you see what I mean? So this is kind of, I see what you're getting at. It does feel odd to explicitly indicate in your code that there have been no errors when the program runs, as if you're promising error-free execution just by stating return 0 in the source code. Yes. So in C, return 0 at the end of main is a convention to indicate to the operating system, or whatever called the program, that it completed successfully. It doesn't mean I guarantee there will be no errors. Instead, it's more like saying, given how things went, I have no errors to report to whoever called me. This makes no sense now. When you return 0, you're not preemptively declaring that nothing will go wrong. Rather, you're telling the operating system after the program has run, everything seems okay up to this point. On the flip side, if the program encounters a significant error, returning a non-zero value can indicate that something went wrong. Return 0 doesn't predict an error-free execution, but it's just a standardized way to let the system know the program completed successfully if it reaches that point without issue. But isn't that like self-evident? The program completed successfully. It's kind of weird. It does feel a bit self-evident. It seems redundant. Yeah. It's communication with operating system or calling process. So the operating system or any other program that may run your program often needs a clear indicator of success or failure. This is especially important in larger systems or scripts. The return 0 is a formal way of saying I'm done and everything's fine. What do you mean I'm done? Okay, what does Rust do in this sense? The concept is similar but with more agronomic approach, reflecting Rust's focus on safety. Implicit success in main. The main function doesn't return a value explicitly. It's treated as if it's returns success by default. So you don't need to write anything to indicate success. Reaching the end of main without issues implies everything went well. So result in main. Rust also allows main to return a result type, which is a more expressive way to handle errors. If you want to signal errors explicitly, you can write main like this. fn main result box standard. Okay, wow, I don't know if this is error codes. Yeah, it's kind of, when a C program returns, this indicates there have been no errors running the program. It's just the sentence sounds kind of confusing. It does sound confusing. Well, I'm just saying from my perspective, okay? The sentence, for me, it's confusing. Compilation. Before we can run this program, we need to compile it. This will produce the actual executable we can run on our computer. Open up the command line and browse to the directory that hello world C is saved in. You can then compile your program. All right, so let's write this. So we're gonna use GCC and standard 99. Standard 99, okay. Wall, hello. Because maybe we should do 11. I don't know. We'll see how it does with 11. So with this, you declare the, I guess the, what's it called? The programming, like in some years, I guess they define some sort of a standard for the language. And maybe this was in 1999, but there was a standard in 2011 and 2023 or 22. I don't know when it happens. Does it happen every year or not? Okay, wall, hello. Does it autocomplete? It does. And oh, hello world. Also snake case. Unrecognized command std c99. Okay, std c99. So now if we write hello world, it prints hello world. And if we do file type, I don't have a file here. Okay. This compiles, reporting any warnings, outputs the program to a new file called hello world. Does it print the same thing with 11? 23, let's try 23. Did you mean std c2x? Oh, it's smart a bit, okay. It does print. You just compiled and run and your first C program. So, okay, errors. If there are some problems with your C program, the compilation process may fail. These issues can range from simple syntax error to other complicated problems that are harder to understand. Sometimes the error message from the compiler will make sense, but if you're having trouble understanding it, try searching online. This is about debugging, documentation, reference, bonus marks. It's written change the hello world. These are a couple of assignments. Change the hello world greeting given by your program to something different. Well, we could just change. What will happen if we just puts hello world, my name is Domagoy. So if we GCC expected before return, so it doesn't, I didn't do the, oh, I didn't do it, yeah. I forgot the semicolon. Let's see if it does hello world, my name is Domagoy. So I think the difference between puts and printf, I think there is printf. That's how much I know from C. So if I do now hello world, yes, there's no new line. Puts. Yeah, there's no new line. Change the hello world given by a program to something different. What happens when no main function is given? When no main, I guess it will not work. It will complain. What if we change it? What happens when no main function is given? What do you mean it's not given? I'm not sure. Do I just delete this? Why just delete this? But this will not work. So hello world expected identifier before token. Yeah, do I do like already at the oldest change? Oh. Yeah, it's really bad. You see, when I go out of Helix, I cannot undo what I wrote before. Let's find it again. Hello world. So let's write this again. Int main. So int main is the name of the function, and int argc are the parameters of the function. This was same in Rust, right? So this kinds of, wait a second, will this build I'm interested if this is going to build int main. So Rust actually can build this. Maybe I'll just open up a new tab, yeah. Then I can change with this, yeah. So let's see if this, oh, it does work. It does work. Int main, so int main empty parameter list and then curly brackets. All right. Let's just continue. And what if we don't put the return? Int main and return. Int main. Where did I put installation? Int main, int argc, char, star, argv. There is space here. So let's see if this builds. It does build. Okay. So Let's do puts hello world. Let's do like this. It does build. It does build without the return. Return 0. And we build it and it does work. And let's just try one more thing. Let's put 1. Does it build? It does build even with 1. I thought it will not work. Okay. Compilation. This compiles code. Is mentioning Valgrind and GDB for debugging. I guess that's not important for now. What is this book? Use the online documentation to look the puts function. Look up how to use GDB and run it with your program. How do we run GDB with a simple hello world program? How do we run GDB? So GDB is a debugger with our simple hello program. How do we, I think, do I have GDB installed? Compile with debugging symbol. So use the G flag to include debugging information into the compiled program. This enables GDB to debug the program. Oh, so I have to include, right, let's see. std g, I guess we put a flag here, g, required when input is from standard. No, I should put this here actually, I think. No. Try it here. No. How to include this -g here? I thought GDP can just run it. G hello std. Yeah, but this didn't work. Wall. Oh, I have a mistake here. Right. I don't have GDB installed. Let me quickly install GDB. I'll just put it here. So start GDB with your program, run GDB and pass in the executable you just compiled. GDB hello world. Yeah, I guess this is just kind of just to see what GDB does. Steps into functions, executes the next line of code, debugging. All right. Ah, all right, I said. Okay. I guess I'm saying all right when I'm waiting. Yeah, someone wrote a comment, all right, all right, all right. Maybe I'm saying that a lot. All right. Now Nix is kind of slow. Okay, we'll look at GDB. So, okay, let's go back to basics. So a program in C consists of only function definitions and structure definitions, right? and we can call the functions between themselves and use any data types, right? And call them from other libraries, right? Now we're going to go to do variables. Functions in C consists of manipulating variables. So these are items of data which we give a name to. So every variable in C has an explicit type. Now these types are declared by ourselves or built into the language. Are these called primitives? Primitive types, maybe. We can declare a new variable by writing the name of its type followed by its name and optionally setting it to some value. And this declaration is a statement. And we terminate all statements in C with a semicolon. Oh, so he's saying that defining variables is called statements. And other thing is defining functions. So let's say int count is 10. So count is 10. That's a statement. And when we define main, that's defining a function. So that's not a statement. I thought in C, like you call everything basically statements because it's about state. In imperative programming, you define basically through statements. Do this, do that, and then do this. So these are kind of statements, and they destruct the state because they constantly keep changing state, what's going on. Okay. I'm kind of thinking out loud. GDB. So we do GDB. Let's just see hello world. GDB type red for more, for help. So GDB hello world. So these are like basic commands. Let's see what run does. Starting thread debugging using host lib thread. Hello world inferior one process exited normally. Set a breakpoint. Example at main. Break main. Breakpoint 1 at, and this is a location in memory. So is this a location in memory? And now he says step through the code. So steps into functions and next executes the next line of code without stepping into functions. So steps print variable values if you have any. Print variable name. So if I do step, the program is not being run. If I do next, the program is not being run. Do I have run? I have run. Main argc argv at hello world C4 puts hello world. So if I do next, hello world. If I do step, I have the closing brackets. Next. From next, it's showing me the next store. That's interesting. If I do next again, single stepping until exit from function libc start call main, which has no line number information, exited normally. The program is not being run. Interesting. All right, let's just quit this. It was kind of, I guess there will be time for this. So create a new int called count. We could write the following, int count, or to declare it and set the value, int count. Could I do this in okay, come on, where is the, maybe I can do it here also. Puts hello world. I should declare it here, maybe. Int count is 10. right? Yeah, I'll just quit here actually. So let's int count, unused variable count. Oh, we declared int count is 10, but we haven't used it. So we cannot do that. Int count 10 puts hello world. How would I use this? Int name, string name, I guess. How would I do string name, hello world? Let's do something very simple. This ChatGPT will know this. Let's do something simple. I want to declare a variable and put my name in it and then call it from puts. Morning, hi, then call it from puts, then call it from puts, right? I want to call it from puts. Char name, it's like that. Okay, yeah, all right. I'm just trying stuff. Char name 10. No, car. I think it's spelled car, right? Car name or char. I'll sometimes say char. Car name is Julio. Let's try Julio. Print my name is, it's like that, right? Hello world. Hello, it's this thing. Hello, yeah. This, but I need to do it outside. That was like in Rust, name. And you call it a name, right? So if we do like that, and we do it, puts const char extra. What did I do wrong now? I did something wrong. Oh, my name is return 0, char name, use printf. Oh, it doesn't work with puts. Printf, yeah. That's interesting. Extern int puts hello and wait. Oh, this here. This here. Oh wow, an int. Why is it doing int? Because I have int main. Yes, I was doing this. Is this because I have int main? Hello world format expects argument of type char, but argument 2 has type int. Main. Yeah, I've kind of changed the example a bit and now it doesn't work. Return char name. Char name. Oh. Is it this? Really? Yeah. Hello Julio. But I have, because it's printf. I don't, that's because of the new line, I guess. So where do you put the new line? You put it outside. No. You put it inside, I guess, like this. Is it like this? Yeah, hey Julio. Yeah, the idea is that a string is a vector of characters. Yeah, but is that actually the term used in C? Do they use the term vector? You know, sometimes it's a list of, it's like a string is a list of characters in Haskell. A vector, really? I thought, okay. Yeah, okay, I'll just continue. I'm doing through the, you know what? I'm going through the book of Build Your Own Lisp in C. So yeah, I'm just going to read through the book a bit and then thanks for the tips. Really, that's nice. Are you doing C? Do you like know C? To create a new int called count, we would write the following int count 10. And here's some description as examples. These are like built-in. Yes, when you use star, you are using a pointer to a car. It points to the first car in the vector. So when you use the star, oh yeah, pointers. So it points to the first car in the vector. But the vector is about, I'm gonna, actually, this is interesting. Where is helix? Why is this? It's not. So when you use in C, when you use star with car, I just copy pasted what you wrote. It means that pointer points to the first character in a sequence. Character array. Yeah, I was kind of, because you said vector. You said vector, or is it an array? Or I guess it's the same thing. I mean, pointer to the first, accessing the characters. Here's a quick example. All right. This Ask GPT, he will explain better. I don't speak English. I'm from Brazil. All right. Okay, thanks. Yeah, it's just this pointer-based approach allows you to traverse and manipulate strings efficiently in C. Oh, by incrementing the pointer +1. Ah, that's how you do +1, +1. So the star accesses the first one. All right. Array, this is an array. Okay. So is there a difference between a vector and array in C? A continuous, okay, a contiguous block of memory with a fixed size. I thought that's a vector, right? Maybe that's more mathematical term that holds elements of the same data type. Once an array is defined, its size cannot be changed. Fixed size, efficient indexing, while C itself does not have a built-in vector type. Okay, a vector is commonly used, is a type native, to describe a dynamically resizable array. Okay, that's something. Resizable array. Vector is a container. Vector is a container. Yeah, what does that mean? I mean, I know, yeah, there's so many meanings of these words. They mean this and that, in this and that. All right, all right, I said again. Okay, I'll continue now. So we have a void, which is an empty type. And we have a car, single character byte, a single character or a byte, car, last initial H. Okay, int in integer, a long integer that can hold long values, float, that's a decimal, and a double. Vector is a container. Vector is a container. What is meant by vector is a container? Implementation, oh, is an implementation of a library. Yeah, okay, I see. It's more like a general word. A container is simply a data structure that holds and organizes collections of objects. Store, access, iterate. What is a vector? Yeah. All right. A function. Okay, now it's function declarations. So a function is a computation that manipulates variables and optionally changes the state of the program. Yeah, it is about state now. It's a computation that manipulates variables and optionally changes the state of the program. It's kind of cool because he's doing a Lisp. So I think, I mean, I haven't read any C books, but I think the way he describes this is kind of more. It's functional in a way, and optionally changes the state. It takes as input some variables and returns some single variable as output. That's like functional programming, right? It takes an input and returns a single output. To declare a function, we write the type of the variable it returns, the name of the function, and then in parentheses, a list of the variables it takes as input. Yeah, that's like in Rust. Separated by commas. You separate them by commas, and you write the type. You write the type here. But you only write, I guess you would have to, if you had your own types, I guess you would have to define them first and then declare them. Or this is only just for the primitive types that are types that are already here. The contents of the function are put inside curly brackets. My cat is trying to eat the box. The contents of the function are put inside curly brackets and lists all of the statements the function executes. So the statements the function executes, terminated by semicolons. A return statement is used to let the function finish and output a variable. So for example, a function that takes two int variables called x and y, adds them together, could look like this. So I'm gonna just, because I have to type these things, let's do add C. So I only have the function. I don't have the, you see, I already forgot int add together. I would need the main. Should I need a main? Because this won't work. I don't think this will work. Int add together. You need the main to call the function, right? Could I put the main at the end? Like you do int add, int this, int that, and at the end you call a main that calls int add. Is there a way? Yeah. Wait, I'm gonna check this because I'm not sure how to write there. Is there a way to, in C, to first write the function such as this, and then call main that calls that function? You need the main. You can declare and define a function before main and then call it from main. Define the function before main. Yes, int add together and int main and sum add together. What if I don't want to sum? No, I just want to call, I just want to call the function in main. I don't want the function to do something within main. Is there a way? No, he's not. Is he under? Yeah, I can call it here with, oh, this is cool. This looks kind of functional. So I do have to, yes, include standard IOH. And we're going to do int add. I'm just going to call it add together. I don't understand this add together, right? How do you not add together? Okay, yeah, sum, int sum. But I guess sum is not already defined, right? Int sum, do I have to put space? No, int x and int y. And then we can try sum of squares. I like to do sum of squares. Int result x plus y. No, it will work. Ah, it works. Yes. Int result x plus y. Return result. So, and now we're gonna do int main. Open up the curly brackets. And we're gonna call add together. No, we're gonna call sum with the values that we will provide to the sum function that has the parameters x plus y. So we're gonna give it, yeah, let's do 3 and 4, but we still have to do return 0. So this should work. I again put this in tab 1. I want to keep this. I want to keep this in tab 1. Did I save this? Oh. Sum. hx add. So sum 3, 4 return 0. Yo, I didn't extract it to print it. So I guess it will not work. I mean, it will work. Will this work but not print? Wall sum c. No, it's add c. Add c o add. Add c add o. No, add. Yeah, it won't work. You can't see it. Right, I need a printf. So int main printf. I should do it here with printf sum. Can I call printf on sum? How do you call printf on sum? Sum 3, 4. Is there a way to, yeah. So I have to call printf on sum. Can I call, I could do it here. Can I call, I have to do this in chat. The chat is good for these things. Like, can I call printf sum is, yeah, that's the same actually when we put a variable in a placeholder, but we have to use the D, not the S. S is for characters, right? Or C? Yeah. So we are going to do printf, yeah, printf sum. Yeah, D is to print integers, C for characters, yes. Sum is, where is it, this thing? Sum is D. New line. Okay, we're going to do the new line, double quotes, comma, and this, and yeah, just this. And we need one more to close it, and return 0, right? Perfect. And now we do add, sum is 7. This is nice. Sum is 7. So I guess the same would be here. So in sum, I guess I can change in sum. Yeah, I could do, wait, I could do sum. I'm just going to do one more thing. In square, int x, int y. In square, maybe I could call sum from square. In square, I don't know how to do that. In square and inside sum xy. No, wait, int x, int y, and in square x. Only x. Yeah, wait. Int x, return x times x. Ah, you're right. I don't need to do x, y. Yeah. I don't need to do it. I could just have int x. Yeah, I'm not thinking. Yeah, and int result is x times x, and return result. So now we have a square and a sum, and sum of squares. Sum of, I should have changed this. No, I could save this as a new. Sum of squares is this, and sum 3, 4, and now I have to call sum. And how do I call it? Do I call it after sum, or sum of squares is this? Sum of squares of x and y. No, I should have sum of squares of x. Yeah, this should be a little more of x, I guess of d and d, right? Yeah, now I don't know basically how do you call more. I need 3 placeholder for the x and for the y and for the sum of squares. Sum square, square 3, 4. Oh, sum square 3, square 4. Yeah, I thought to, okay, sum square 3, 3. How do I do d and d is d? I think this is wrong, right? Okay, I'll just put this a little bit. Yeah, I get this. Sum square x square x like this, square y, only 1d. No, yeah, but I wanna, okay. Wait. So let's say 3 and 4. No, because I want to sum of square before declare x and y. Int x3. You see the thing I want, int 4. I want to output the sum of x and y is square sum x and y in this example. Add together, yeah, we have this. He's doing it here in main. In sum is add together, in square sum and sum. The sum of x and y is d, and its square is d. Oh, he didn't do what I said. Int together, wait. Int add together, int sum. Oops, wait a second, I don't have really... this is, I should delete this. And square and main. Wait. No, just fix this code and show me how to put the values in the statement as well of x and y. Printf sum of square d and square d is d. Yeah, so that was correct. And then you just put them x, y, and sum square x square. Okay. Can you change like in Rust, like you can put like curly brackets 0, 1, or 2, and then you can change like, okay, wait. And sum x, yeah, now he did it. Main x is 3, y is 4. Ah, he did it here. Look at this. This is nice. This looks better, right? Square results, square results. This kind of looks better. This is more functional because I was doing the calculation here in the printf statement, which is kind of not so. This is better. So he's doing int x. Yeah, this is nice. Int x is 3 and y is, let's put 5. Okay, let's put 4. Int x 3, y is 4, and then he's doing int sum is what? Sum result. Oh, he's doing the sum. Int sum result is sum of x and y. Needs the semicolon, and then I guess it's square result, right? It's square result. More clean code, yes. Square x and y. This should be the same, right? Square. No. Square sum result. Yes. I wasn't thinking. Square sum result. Square sum result. Because you square the sum of the x and y. And then the sum of squares, the sum of d and d. Okay, this was just, he wrote it a bit differently. So sum of squares of d and d. I don't know actually what makes more sense. The sum of d and d is d, and the square of the sum is d. Okay, it's kind of a different way to, and the sum of squares of d and d is, I like this kind of it because it's shorter. The sum of d and d is d, and the square of sum is d. So the sum of squares of d and d is d. And then he's kind of just calling them x and y and sum result and square result. But it's interesting, there are 3 Ds, D, D, and D. Okay, D, D, and sum. Oh, there are 4 Ds. The sum of squares of D and D. Ah, because he called a sum, and I changed the sentence a bit. So I'll have less Ds. I don't have to call. So the sum of squares, the sum of squares of d and d is d. So I will call here x, I will call here y, and I will call here square result. Return 0. This should work now. How did I call this? Add. Well, I should call this sauce C. Yeah. Sauce SOS. The sum of squares of 3 and 5 and 4 is 49. Oh wow, this took a while. This took a while. All right. This took a while. So we had an int sum and square int main square. All right. Let's continue. I'm going to continue. Int result, return result. So we call functions by writing their name and putting the arguments to the function in parentheses, separated by commas. Right? Same as here. Int x, int y. That's what he's saying. For example, to call the above function and store the result in a variable added, we would write the following. Oh, that's what we did. Int square. We didn't do this. No, we did do it here in sum result. We did it here in sum result. in a variable added. Yes, we did here the variable sum result. Inside we put the sum of x and y. Okay, that's what he's doing. So now we're going to do structure declarations. So structures are used to declare new types. Okay, I guess these are types that we will have in our program. Similar notes. Structures are several variables bundled together in a single package. We can use structure to represent more complex data types. For example, to represent a point in 2D space, we could create a structure called point that packs together two float decimal values called x and y. To declare structures, we can use the struct keyword in conjunction with the typedef keyword. Our declaration would look like this. Typedef struct float x, float y, point. Now he's not, I guess he's not, I don't know. I don't think I'll try now to write this in main. I guess he's now trying to go through this. But okay, it makes sense. Typedef struct. And also curly braces. I guess here, maybe, can you have options in struct? Float x, float y, and then point. So this is interesting. Has a point at the end of the curly brackets, point. So I guess at the end of it, you write what it defines. Is this the name of the type of what it defines? So point is a type that has a float x and float y. Is that the name of the struct? I'm just curious. Is that the name of the struct? Is the point the name of the struct? Yeah, I mean of the new type. Yeah, point is the name of a new type. Yeah, explanation, define a new type, typedef, struct definitions, point, that's the definition, then point P1, and then you can use those types. But it's not the use those types, right? It's, well, I guess the float is a type. Yes, you can use, yeah, this is like a type constructor. Yeah, you could do like string fall and then string summer and string winter. And then the point would be seasons, right? You would call that struct seasons. Autumn also, wait. Did I forget something? Yeah, you put the 4 seasons as string, and at the end you write seasons. That would be the struct typedef. We should place this definition above any functions that wish to use it. This type is no different to the built-in types, okay? And we can use it all the same ways. To access an individual field, we use the dot, followed by the name of the field such as x. So point P, and then, point. And then we do point P. Wait a second, we do point and P. Okay, P is like a new thing. And then Px, 0.py. And then float length is square root Px times Px plus Py, Py. Okay. A struct is constructed using other structs and primitive variables. Yeah. Okay. So this thing could be defined, yeah, string, okay. Pointers. A pointer is a variation. It would be nice to make some kind of a simple example of this and to call, or maybe, I don't know, it's important to type things out, you know. Wait a second. Let me quit this, SOS. Typedef, HX, typedef, seasons. C. Can I do int main? Yeah, I have to put int main also again. Include standard input output H int main. Can I do like this? Will it work without the argc, argv, and type def struct? So we do, okay, we open up another curly and string. How do you declare a string in C? Just like string, string fall. Can I do it like this? String winter, string, what's next? Spring, and string summer. Can I do it like this? And then we're gonna call it seasons. And yeah, string does not exist. But how do you a char? Oh wait, nah, you're right. It's a car. It's not a string. It's a car. It's like this. No? Yeah? Oh, I'm car. No, it's not like this. Wait. I want to declare a struct of season like this. String does not exist. Almost there. You define a type def named seasons, which contains 4 cars. Declare a seasons. Is this correct? Oh, stop it. Fall, winter, spring, summer, seasons. Declare a variable of type seasons. Seasons, my seasons. I declare a variable of type seasons. I see. So this is correct then. It's just I have to do, okay, seasons. We're gonna call it my, do you do snake case? See, my seasons. And then we're gonna assign values to each season. Oh, that's nice. So we're gonna do my seasons. How do you call it? With a dot. Yes, we call it with a dot. My seasons, we're gonna call seasons dot fall. And September to November. Let's call it, let's do something else. September to November. Let's do favorite. My seasons. A struct would be a person. Inside you could put name, height, and age. Yeah. Let's do this. My seasons fall. For example, yeah. Winter is like Jason, I guess, right? Let's do not favorite. No, let's do lovely. Lovely. My seasons. Spring. Spring is smelly. My seasons. Summer is sweaty. Is it with one T or one? Sweaty. Or let's do hot, very hot. And okay, now my seasons fall. My seasons fall, winter, spring, summer, hot, very hot. This should probably work already. No, I didn't return it. I want to do it here actually. Return 0. I still don't get it why I have to do return 0. You know, because it's like me saying before the thing is done, hey, it will be fine. You know, but it's kind of confusing. Yeah. So how did I save this thing? Oh, okay. So seasons. Oh, seasons. This is the value that your program will return to the OS. Yeah, it's just weird that I'm actually telling it what to return and it's always 0. It's like, it will be fine. It's like, how come the program cannot do this by itself? It's just, I guess someone coming to this for the first time, like, why does this not happen automatically? I think in Rust, you don't have to write a return statement. Or maybe it's because you might need it for something else, like return this or that. A variable my season set but not used. Oh, I didn't use it. My seasons return. Okay. I guess I have to have some kind of a print statement. Print, yes, print each season with its values. Other programs can use this return. Oh, but if you want, you can declare void main and not put the return. Okay, that's when you put void main. Okay, without the return. But you say that other programs can use this. Is it like a pipe thing? So then like, yeah, like a pipe? No, it's not like a pipe. Printf. Oh, yeah. Okay, fall. Let's just print 1. Fall. Fall. And now we do this s, because it's a string, and again, we have to call the entire thing my seasons fall. And this should work now. All right, seasons fall favorite. Nice. My favorite. Okay, so this works. It's I could just, wanted to type this thing, and now I could do the, as you said before, the person, age, job, and stuff like that. Okay, seasons. Let's quit this and continue. So we should place this definition above any functions that wish to use it. This type is no different to the built-in types, and we can use it in all the same ways. To access an individual field, we use dot. We did that, followed by the name of the field, such as x. Float length, he's doing square root, px. Oh yes, he's accessing the values that are declared here, just as we access the fall. No, we had the fall as the x. Oh yeah, okay. Instead of the x, we had the fall. And here we had like a description of the season. So then we had fall and the value. Okay, pointers. So a pointer is a variation on a normal type. A variation on a normal type, where the type name is suffixed with an asterisk. Okay, this definition basically just describes how the pointer looks like. It doesn't really say what it is, except that it's a variation on a type. So for example, we could declare a pointer to an integer by writing int star. So we already saw a pointer type car star argv. So this is a pointer to pointers, to characters, and is used as input to main function. So pointers are used for a whole number of different things, such as for strings or lists. These are a difficult part of C and will be explained in much greater detail in later chapters. Yeah, Julio, do you think, you are from Brazil, Kikfoy. This is all I know. I was wondering, do you think that if you learn, because I started to learn Rust, but then I went to C now, because one of the reasons is that I will build, so to say, a more appreciation for Rust by doing C, but also maybe a more appreciation for C. I don't know. Does that make sense to you? because it sounds like like C, when I do it like this, it sounds like a very nice, you know, minimal subset of all of these things that are implemented in Rust. So I don't know, I just find it now, you know, after doing a bit of Rust, I find it like nice and cool to do some C. What do you think? What are your thoughts? Pointers are used for a whole number of different things, such as for strings or lists. These are a difficult part of C and will be explained in much greater detail. Okay, don't let them scare you. Woof, woof. A short-haired one. Pointer. Strings. In C, strings, pointers are variables that store the memory address for other variables. Yeah, that makes sense. So like pointers are variables for variables, but they point towards memory location. Int A is 10. All right, you're giving us an example now. Int A is 10 and int star P is, yeah, ampersand A. So P is 15. But wait, how did you get 15? Wait a second. Print FD and A. Because A is 10. And print is print 15. Wait, okay, let me parse this. So int A is 10. We have a value 10 and we bind it to A. And now we declare star P and the ampersand A does, I change the value of A using the pointer P. Oh, it's like mutable now. I changed the value of A using the pointer P. But can you do it without the pointer? Let's say you do int A. Ah, you changed it with, you changed A through P. Wait a second, that's really cool. A means that I'm getting the memory address of A. Oh, that's so low level. So it's not like A is 10 and then you put A is 15. That's really cool. Wait a second, now you just, that's very powerful, but it's very low level. Wait a second, I'm smiling, which means it's cool. Wait, wait a second, it's so nice when it's a very different vibe when you read a book or you do something and when it's someone here, and because you can pass pointers in function parameters and change the variable itself. Yeah, but how do you keep track of that? So I really like your quote here. It's really short. Exactly. You've demonstrated a key feature of pointers in C. Bravo, Julio. Directly accessing and modifying memory. So here's a breakdown. Really thank you, because this kind of moved something in my head when you gave this example. Here's a breakdown. Let's just go through this quickly, and here's a breakdown of what you've done. So int P is ampersand A. So P is declared as a pointer to int and is assigned the memory address of A using the ampersand A, because you can pass pointers. So I guess it would not be the same. Like in other languages, you could do int P is A, and that means P is A. But this is different. A star P. Well, that's I've never seen so low level thing. I think this is the most low level thing that I saw. A means the address of A. So P now points to A. But wait a second, P points to A, but it's still 10. It just points to A. And P is 15. So the P, but you're changing the A, but you're naming it P. The connection, actually that's the pointer. So the pointer itself, no, it's not 10. But I mean, before you change it to 15, it's still 10, right? is the memory. Yeah. So this is not a 10. Yeah. No. Okay. Yeah. This is not. This is actually the memory position. That's so low level. Wow. That's so nice. This is really cool. And then you change it, but yeah, I guess that's why you have a word for this. It's called a pointer. So the the pointer is basically about 2 points. It's called a pointer, but it's about 2 points. It's almost like a line between 2 points, right? It's like pointer a like a line between what? No, it's a connection. No, it's a connection. But you're a pointer to end, and it's assigned the memory. Yeah, because I'm trying to almost think of it, because I'm pointing from where? From where am I pointing? The address of A. So P now points to A. The P syntax dereferences the pointer. Oh, meaning it accesses the actual memory location that P points to, in this case A. Wow. So when you do this, now it's accessing it, or as you say, dereferencing, because before, when you declared this was a reference, and now it's dereferencing. Dereference. It sounds like something from Tron. Derased, dereference. Okay, wait. By assigning 15 to P, you're directly setting the value of A to 15 through the pointer. So you're not really, oh, I had no idea, because I saw just in, like A is 10 and then A is 15. But this is different. This is a different kind of low level magic. So printf A, printing A confirms that its value has indeed changed to 15. So the output will be 15. Why this is powerful? Directly modifying values in memory, which is useful for efficient data manipulation, pass large data structures like arrays to functions by reference instead of copying. Wow! Why am I smiling? Wow! Wait a second. You can pass large data structure. So you mean you can pass like a whole building? I'm just saying a building, but you can pass the whole thing with a pointer? Pass large data. I'm so laughing. I'm kind of happy. This is what we call passing value by reference. Yeah, I heard this, but I've never done anything low level. I asked GPT for an example of this. Directly modifying values in memory, passing large data structures to function by reference instead of copying them. So you don't have to copy them, but you destroy state. You don't have a memory of it, right? What if you have to go back in time? But you say memory. No, because it's call by value. All right. Yeah, I'm coming from call by need when I'm talking like this. Work with dynamic memory, allocating with malloc and so this is malloc and calloc, allowing you to manage memory manually. Wow. This is really cool. What is it again? Give me the simpler. Okay. Wait, I really like this so far. This was really nice. Let's just continue with the book. I could now go into a huge rabbit. I'm really happy. This was so nice. I've never really, it clicked a bit, it clicked a bit, and you can like see it's like someone opened a kind of a window. It's like, ooh. For now, remember that if you use car, you can read it as a string. But it's okay, conditional. Conditional statements let the program perform some code only if certain conditions are met. To perform code under some condition, we use the if statement. This is written as if, followed by some condition in parentheses, followed by the code to execute in curly brackets. An if statement can be followed by an optional else statement, so it doesn't have to have an else statement like in Haskell. Yeah, I'm not sure in Rust if statement, did you need an else statement? Is it required to have else statement in Rust? I'm just curious about this. Else is not required also. Okay. The code in these brackets will be performed in the case the conditional is false. Okay, so the code is in else statement. So if true, else false. We can test for multiple conditions using the logical operators. Okay, that's and, that's or, and, or and for and. Okay, inside a conditional statements, parentheses, any value that is not zero will evaluate to true. Inside a conditional statements, parentheses, any value that is not zero will evaluate to true. Okay, this is important to remember as many conditions use this to check things implicitly. So if a value is 1, it will evaluate to true. Yeah, like the first thought that I had now was when you do return 0, it's kind of, it will pass, and return 1 is not. But now it says any value that is not 0 will evaluate to true. And anyway, it was just a thought. If we wish to check if an int called x was greater than 10 and less than 100, we would write the following. All right, now we're going to have an example. If x is greater than 10 and x is smaller than 100, yeah, put this, else put this. This is kind of simple. And if x is greater than 10 and x is, so we put this in parentheses and put, I wonder, okay, we put the brackets. Why didn't put the wait, else? I'm not, yeah, what's the formatting style, I guess? If, let's move on. Loops, if x is greater than 10, or put this, else x is less than 11 or greater than 99. All right. So loops allow for some code to be repeated until some condition becomes false or some counter elapses. So there are two main loops in C. The first is a while loop. So this loop repeatedly executes a block of code until some condition becomes false. It is written as while followed by some condition in parentheses, followed by the code to execute in curly brackets. For example, a loop that counts downward from 10 to 1 could be written as follows. A loop that counts downward from 10 to 1 could be written as follows. So, yeah, let's do this actually. I want to do ls hx, let's do countdown C. Again, include standard IO H. Oh, I forgot. And I guess I could do int main void main. No, void main. Like this. Void main. Void main. Void main int I is 10. And yeah, this is conditional. So while this is while I guess is less than 10, semicolon, no semicolon, right? Because these are arguments to the function. Is this a function? While is not a function. It's a loop. It's not a function. So while I is 10 and puts, what is this, loop iteration? Okay, loop iteration. So how would I write this? Yeah, we need a I, that was always confusing to me. I is I minus 10. The way it stores and then counts. No, I minus 1. Yeah. I want to check also with ChatGPT this. So I always found confusing the way iteration is done here. Inside while is true, it will execute the loop. I is I minus 1. But so how does this evaluate in this example? As long as the argument inside while is true, it will execute the loop body. Int I is 10 while puts, okay, why this code won't run? Wait a second, while I less than 10. It says it's wrong. Why does it say it's wrong? So the condition in while I less than 10, I greater than 10. Wow, yeah. Oh. But where did you see, I'm always confused with loops. While I is greater than 10, loop iteration. I start at 10. Oh, it starts, oh, it counts down. Yeah. It's I've started from 0. It's kind of not, it's kind of cool like how our mind works. So if I do and stop loop, right? So it's and you know who actually described this? No, okay, I will not go there now. Int I 10 while I, so I is while I is greater than 10. You see, I'm still confused by this. So the int I, we bind 10 to the I. Doing the opposite starts at 0 and goes up to 10. Yeah, loop iteration. Let's change this puts. Wait a second, loop iteration downwards. How do you put it down? Loop iteration downwards. So int I is 10. So we bind the 10 to the I. But while I is greater than 10. Wow, I'm still confused by this. Fascinating. Fascinating. I'm kind of confused by the fact that we bind I, we bind 10 to I, and then in the while we say while I is greater than 10. I find that confusing. It's like it's not clicking, you know? It's not clicking. You're absolutely correct to be confused here. The code has a logical flaw in the while condition. Wait a second, again I wrote something. No, wait. Why is this? What's going on? Wait a second. corrected condition to run, but you're copying it wrong. It is I greater than 0. Oh, I'm confused by my own typo. Oh my God. I just couldn't get it. Like I is 10 and while I is greater than 10. Nice, nice. Yeah. Okay, I copied it. Yeah, I have to explain to ChatGPT. No problem. Oh, look, a smiley. All right. So int I is 10. I is 10. Okay, the I is 10. That's the counter, the total counter. So the I is the total counter. And while I is greater than, you know who explained this? Wait a second. What's his Graham Hutton, programming in Haskell, PDF, and there was a part he's describing a while loop in the forward. Features of Haskell. Forward. Wait a second. Acknowledgements. I like this. Double. Squaring, sorting, sequencing. First steps. Where did he... Java. It's not in this book. That's funny. I remember he really nicely... Yeah, anyway, I'll just give up. Wait a second. Forward. Oh, I think it's here. Sequencing, first steps, standard prelude, chapter, type classes. I don't know, where is it? Let's be fine. Graham Hutton Java. Yeah, anyway, I mean, I like Graham Hutton because he can use, he uses words. Solving the countdown. Yeah, the countdown problem. Ah, this is taking too long. Yeah, I don't know. Yeah, okay. So while I while I is 10, while I is greater than 0, loop iteration. So yeah, also this is upwards. Loop iteration up. Let's call it up. And I is I minus 1. 10 greater than 0. Execute the loop. True. Next. Oh, I get it. I get it. So the first, I really have to do it in steps, right? So int I is 10, okay? And while 10 is greater than 0, you loop this thing. And then you do 10 minus 1 is 9. And then, while 9 is greater than 0, write this down, whatever, put this text. And then the third step is, I is now 9. So 9 minus 1 is 8. And then we go back here. While 8 is greater than 0, you put this text, because it's still greater than 0. But now I is 8, so it's changed. The I changed. int I is 10, but we changed the I. We changed it. We changed it. So I is now 8. And then 8, I is now 8 minus 1, it's 7. And so then, yes, this was confusing to me because it's like I declared I as 10. But this I is being constantly destructed. Now it's actually 7. So the while loop, it happens here. It doesn't happen here. So the int I10 is basically at the beginning. It's not involved. Will only run once. Yes, that's why I was confused. So int I will only run once. You say like this is going to be like this. Int I will be 10. And then while 10 is greater than 0, do this. And then I minus 1 is 9. The loop only executes the curly brackets after the while. Yes, exactly. It's a very stateful operation. Yeah, because I've never learned actually imperative language, so I'm kind of trying to wrap my mind with this. Puts lap iteration up, I is I minus 1. And if we had int, we could do void main. Let's call this, can we call this like a function count up? Like you see, if I do like int a is 10, and while a is less than 10 would be then, no, wait a second, I'm doing the same thing. A is 10. So while A, because I'm not used, you see, A is not the same A. Go from 0. Yeah, I know. It's just, I guess I'm used because of the functional programming. You do A is this, and then with, functions, you change things. So now I have to, A is 10. And now while A decreases, or like A is less than 10, wow, I'm getting confused. While A is less than 10, no, it's greater than 0, is less than 0. While A is less than 10, you can do the opposite, go from 0 to 10. But wait a second, no, we start with 0. And while A is less than 10, we start with 0. What do you want to do? No, I know what I want. A will be 0. And while A is less than 10, it will put loop iteration up. But wait a second, loop iteration down or up? So A is 0, and while A is less than 10, loop iteration down. And now we're going to do A is what? A, while A is less than 10. Okay, you see, I have to put it inside while instead of puts. Put print iteration. All right. It's so weird. This really takes time to just understand a while loop. I think it will be better for you to see how it works. Yeah, I can. Yeah, I think I kind of get it. I think I have to, like meditate on it, just do it in my head, loop it, and then it will, like int A is 0. So that's the beginning, right? We're going to have it to 0. And while then this does not make sense then if A is less than 10. Because here we had I is 10, and while Wow. A is 0. So while A is less than 10, loop iteration up. So this should be up. And A is what? A plus 1. Wait a second. Let's just try this. I'm not sure if it's wrong. A is 0. Okay, A less than 10. Loop iteration up. So the first A, okay, the first A is 10. The above is down. The first A is 10. No, the first A is 0. So it's 0 is 0 plus 1 is 1. While 1 is less than 10, yeah, put this text. Now 1 is 1 plus 1 is 2. While 2 is less than 10, put this text. 2 is, so A is now 2. So now 2 plus 1 is 3. So while 3 is less than 10, blah, blah. Now A is 3. Now A is 4. Okay, now it's 5, 6, 7, 8, 9, 10. And now it will stop. Yes, this makes sense now. Fascinating. Okay, I think that was, yeah. I think this is enough for now. I will have to, I'll kind of think of these loops a bit more. And yeah. I guess you could make a lot of complicated things like this, but it's so manual. Manual, it's like, it destroys state. Yeah, it doesn't, yeah, the A is constantly changing. For me, the confusing thing was because I thought this A and this A are somewhat different. Okay. I think this is okay for now. I don't want to go too deep with this. I already went far with this. Okay. Let's just see how long was this stream. Hour and 51. Okay. Okay, loop iterations. Okay, the second kind of a loop is a for loop. Ah, another loop. Rather than a condition, which we had here, this was the condition. This loop requires 3 expressions separated by semicolons. So these are an initializer, a condition, and an incrementer. But basically this was an incrementer. This is like an inc. I guess you could define an inc is A is A plus 1, and that's an inc, and you could put an inc here. And then you have a for loop inside a while loop. No? This loop requires 3 expressions initializer. Well, this is also an initializer. Yeah, right? This is an initializer. This is an expression, and this is an incrementer. So it's just a different way how to write a while loop. Initializer is performed before the loop starts. The condition is checked before each iteration of the loop. If it's false, the loop is exited. The incrementer is performed at the end of each iteration on the loop. These loops are often used for counting as they're more compact than the while loop. Yeah. For example, to write a loop that counts up from 0 to 9, we might write the following. In this case, the plus plus operator increments the variable I. Oh, the plus plus is the inc. For int I is 0, while I is less than 10, increment I. I guess this looks easier to parse. I mean, mentally to parse. This kind of than this. That's the same as this. Int I is 0. Yeah, while I is less than 10, A is A plus 1. That's the same thing. I plus plus is equal I, yes. All right. So this is same as a for loop. Yeah, this looks a bit better, yeah. Okay, use a for loop to print out hello world 5 times. Use a for loop to print out hello world 5 times. Okay. Let's do this. So, oh, I already forgot. For. What do you mean? For. Right. I'll always remember parentheses, and curly brackets. So inside the parentheses, we have to initialize it. We said 5 times. But now we have a text. We said 5 times. So I guess the I, really I is 0. Do we have to write a type? Int I is 0. And I is less than 5. Well, I think 6 should be better. No, 5. Will it go to 5? And so we have an initializer, the condition, and what else? The incrementer. Initializer, the condition, the incrementer. So I++. You can put int I before the for, and only putting I is 0 in the for, it's allowed. And only put I 0. Oh, okay. You mean this. Int I, and then you put this. This is what you mean, right? Int I, and now we're going to put hello. You know, I heard Zoding on his stream. He said the small capital hello world is the K and R style, while these days everyone writes H with a capital and W with a capital. So this is the old school way to write hello world. Did you know that? Yeah. You know, I did buy the white book. I did buy the white book like 15 years ago, and I never read it. I just started reading it, and it was too much for me at the time. But I always wanted to have it because I saw the movie, I guess, Hackers, and they said the white book. The white book. So I was like, you know, I was very young. So I was like, I have to have the white book. And then I bought the white book. I gave it to someone. Oh, I gave it to someone away. And that someone doesn't need it. I could ask for it back. Just to show it on the stream. No, okay. Hello, will this thing work? How did I save this? Countdown? No. Let's save this as hello, hello 5C. Hello 5C. Oh, hello 5. No, it didn't work. Return type of main is not int. Oh, void main. Oh, because I put int I. Ah, because I put void main. Return type of main is not int. Is it because I put I? If I do int main, can you do something like this, void? Will this thing work? Ah, it works. Yeah, hello world 5 times. Hello world 5 times. And the white book is so nice. It has that thick covers and they're like so smooth. They're like smooth, thick covers. And it's a really small book. It's a small book. Hello world, hello world, hello world, hello world. All right, we did this. Bonus marks. Use a while loop to print out hello world 5 times. Yeah, I should probably do this. Or do this. What am I doing? Basics chapter. Hello world. HX. What was this? Hello 5. Hello while. I'll just do it. Hello while 5. Maybe this is not the common way. I have to put snake case, right? Hello while 5. See. Include standard H int main void. Let's do it now. Will I while? You see, I forgot. Wait a second. No, I have to declare it. Int I, right. And now while I is, what did we say? 5 times also. While I is less than 5. Yeah, I forgot the way you write this. No. While I is less than 5. Now the curly brackets, right? While I is less than 5. The curly brackets is, we puts hello world. And we are going to do what? The incrementer now it's supposed to be. I is what? I plus, but I didn't declare it here. Int I is what? 5. I plus 1. Let's see this. This is not, so I is 5. No, this is not. I is 5. I is 0. And this should work now. So the I will be 0. While I is less than 5, you print this. So I is 0, 0 plus 1 is 1, 1 plus 1 is 2, and you print hello world. And we have it here also. Let's quit this. How did I save this? Hello while 5. Hello while 5. Oh, hello while 5. All right. Awesome. Awesome. So declare a function that outputs hello world n number of times. How much time do I have? I have n number of time. I have n number of time. Like someone says to you, how much time do you have? I have n number of time, and n is 5. N minutes of time. 11:30. Oh, thanks for the follow. 11:30. Yeah, I have some time left. Use, you know, when I was I used to, my old teacher, when I was a kid, one of my, teachers, he would, when you would say, when I would tell him like what's the time, but I guess at that time I didn't have phone and stuff, so I would say like what's the time, and he will never say like 2:45. He would say 12 or 1 and then add the 45 to 60. So he would tell me now it's 1 o'clock and 105 minutes. And then I was like, I would always have to add. It was so weird, right? And sometimes he would not do it just like one back, but he would do like, I don't know, it's 12. Where am I from? Croatia. Declare a function that outputs hello world n number of times. So what is he doing? Declare a function that outputs hello world n number of times. Yeah, nice. Declare a function that outputs hello world n number of times. N number of times. Well, wait a second. It's 7:38. How many hours there? Oh, 7:38. I thought there'd be a larger difference. Here is 11:36. 11:36 a.m. So morning time. Declare a function that outputs hello world. Yeah, 4 GMT plus. Okay. Declare a function. So do you do C? Like, I don't know if you said that before. Like you do stuff in C. Declare a function that outputs hello world n number of times. Call this from main. But wait a second, he creates a function that receives an int n. Yeah, but why is this anything different than for or while loop? Because so a function that outputs hello n number of so we call it, yeah, she receives an int n, but what's the end? It will be I less than n. But what will be n? Do we give it an n? So like hello world 5, hello world 10. Declare a function that outputs hello n, hello n, hello times C. So okay, again, include standard IOH, standard IOH, include standard IOH. So we need to have an int main. Okay, I'm going to do void. So haven't you learned input yet? Haven't you learned input yet? What do you mean? Int main void. Well, no, I didn't. But it shouldn't be like the book starts like, I think he doesn't want us. So get a value. Yeah. No, I didn't. I mean, I think I know. I don't know it. I know what you mean. But I don't think I think he's kind of also trying to teach here. So I don't think he wants us to give it an n number of times. Or does he? Because he didn't talk about, let's see what it does. Get a value from yeah. Oh, I don't think he didn't mean that. Look, also ChatGPT did that. He meant, I guess, to give the times inside of the source code like this. I think this is more, minimal what he wanted without the scanf. So he wanted us to print the hello world with a for loop and then to call the main with an int times and print the hello world and then call times. Okay, so we have an int main world, int main void. He's doing print. Yeah, I don't have to. He's calling it here int main and declaring it print hello world. That's interesting. So I can do void. Really? Void, and he's doing print hello world with a for loop. Print hello and int n. I didn't do this before. I would before do like int main. So for int n. So you just repeat this. And no, we're doing a for loop. Int I, but you have to declare it int I? No. Yeah. Int I is 0. Yeah, you said we could do this outside. Right? So we could do int I like this. So I is 10. I is... But how do you do? I have to know 5 times. I don't have to know times. Yeah, int n, less than n as you said. And I will be incrementing like this. And now we're going to put inside puts hello world. So this will be, this is 1 and this is here. So I have to put a new one now, right? Declare the function. So for I less than n, hello world. So this is basically the same as before, but we are kind of defining a function that will give this n, bind some kind of a value or maybe some kind of a result to this n. That's the difference. I like this. So before we wrote n will be this or n will be that. Yes, but now it is dynamic. Each time you can pass a different value. Exactly. It's kind of more pure, I guess you could say, because this print hello can have any value. So I guess this is more functional. So now we're going to define, but do you also use void? He's using int main. So if I had more functions, would I do void? Yeah, I guess this is kind of defines a function that takes an integer n as a parameter. It doesn't return any value. So now we do int main. So int times is 5. So that's the n. But why he's not writing n? He could write n. You can change this value to print more or fewer. Int times is 5 and print. And now we are going to call the function print hello with times. Will this work? Yeah. Print hello. I guess we couldn't name it int n is 5. Would that work? Return 0. GCC. This takes a long time to write all this. How did I name it? Hello times. Times C, O, hello times. It works. Hello world, hello world. So maybe this wouldn't work. Use scanf d times just so you can see that it works. You mean this? So then I would actually, that means I would delete this. And, just a moment. Ej, pa evo streamam. Ti? Streamam, evo, pa ću stat sam čekao tebe da se vratiš. A? Da. Ajde. S čime? A nema, da. A ima samo blitve. Pa ne znam, a? Aj ću vidjeti šta ima. I ja ću sad stavit ću stream, pa ću izvaditi šta ima, pa ćemo vidjeti. Ili šta? Ili bi si naručila bi si, ili šta? Dobro. Ajde. Ćao, čao. Yeah, all right. I will have to go now. So really thanks for... Oh. Oh, nice. I really love your language. I love Portuguese. I was crazy for that language when I was younger. I remember I had a few friends from Brazil, and I liked how you guys have a different kind of like meu, like meu more closed e, and wide e, like meu and seu. So I would practice. I would go like in school or seu, meu. It was so fun. And the way you guys talk, nanana, it's so like, bumpy language, goes up and down. Eu sou do Brasil, eu sou da Croácia. Ai, que it's like really, wow, no. It's so nice. It's so nice. Yeah, all right. Look, I will go, and really thanks for the tips in C, and I kind of like this so far. And all right, bye bye. It was nice meeting you. See you soon. Bye bye. Good day. Good day. Stop.